Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss tangent lines and derivatives. Our example says to find the equation of the tangent line for the graph of f of x equals x squared plus x plus 3 at the point 1, 5. Let's carefully work through this example solution. So to find the equation of any line, we need a point and a slope. So we're already given the point in this problem. It's the ordered pair 1, 5. The only thing we need is the slope of the tangent line. So the slope of the tangent line is the derivative. So the derivative of f at x, this is equal to the slope of the tangent line at x. This is extremely important and is one of the biggest concepts in all of calculus. So the derivative of f at x is the slope of the tangent line at x. In this particular problem, we want the slope at this ordered pair. We basically have to compute the derivative of f at 1. We're going to compute this, and then we're going to take 1 and plug that in, and that's going to give us our slope. So let's go through the process of computing the derivative. The derivative of f at x is equal to the limit as h approaches 0 of f of x plus h minus f of x, and it's all being divided by h. This quantity, f of x plus h minus f of x over h, you may have seen it before. It's called the difference quotient. So when we take the limit of this, we get what's called the derivative, which is the slope of the tangent line at x. This is equal to the limit as h approaches 0. So to figure out this first piece, f of x plus h, this is basically saying evaluate f at x plus h, which means that you look at your function f of x, which is up here, it's x squared plus x plus 3, and instead of x, you put x plus h. We're going to put an x plus h everywhere we see an x. It'll be parentheses x plus h squared. Instead of x squared is x plus h squared. Then we have a plus x, but for us it's not x, it's x plus h. I'll put it in parentheses just to add to the clarity. You see it's x plus h squared plus x plus h, just like the formula. And then we still have this 3, so plus 3. The only thing that's been written down so far is the first piece here, f of x plus h. Then we have the minus sign from the formula. And then it says f of x. Well, f of x is our entire function. Because it's 3 terms, we do need parentheses. So it'll be x squared plus x plus 3. All of this is being divided by the whole thing by little h. Beautiful. Let's keep going. This is equal to the limit as h approaches 0. So we can now multiply this out, x plus h squared. The trick is there's a formula. You square the first piece, so it's x squared. You multiply the x and the h and double them. So x times h times 2 is 2xh. And then you square the last piece, so h squared. Worth memorizing. We still have the plus x, the plus h, the plus 3. There really is a minus 1 here in front of this final parentheses, so we have to distribute that. So minus 1 times x squared is minus x squared. Minus 1 times x is minus x. Minus 1 times 3 is minus 3. All of this is being divided by the whole thing by little h. This is equal to the limit as h approaches 0. And at this point, in these type of problems, if it doesn't have an h, it's going to go away. So that's always going to happen whenever you have a quadratic function and you're finding the derivative using this formula. When you get to this step, everything without an h should cancel. So for example, x squared doesn't have an h. Does it go away? Yep, it does. 2xh, it's going to hang out. 2xh. H squared, it's going to hang out. So plus h squared. X does not have an h. Does it go away? Yep, it does. The h hangs out. And then the 3, it doesn't have an h, so it goes away. All being divided by little h. Now we can do something interesting. We can pull out an h in the numerator. This is the limit. As h approaches 0, you can factor out an h. So you'll get, let's see, what do you multiply by h to get 2xh? Well, simply 2x. And what do you multiply by h to get h squared? Well, simply h. And what do you multiply by h to get h? Just 1. All being divided by h. And this is where the magic happens, the cancellation, right? The h's cancel, which is really, really nice. So this is the limit. As h approaches 0, of parentheses 2x plus h plus 1. And at this point, we're ready to plug in the h. So notice I wrote the limit sign every single time. It's really important to do that until you get to this last step when you plug in the number for h. When you do that, that's when you stop writing the limit sign. Okay, so 2x plus 0 plus 1. We get 2x plus 1. So what does that tell us? That tells us that the derivative of f at x is equal to 2x plus 1. So now we have that f prime of x is equal to 2x plus 1. And so what this does is this gives us the slope of the tangent line at x. So now we can plug in any number here and we can get the slope at that number. We want the slope at 1, 5. So we want the slope at this ordered pair here. What we're going to do now is plug in 1. That's going to give us the slope. So f prime of 1 is 2 times 1 plus 1. That's 3. So our slope is going to be m equals 3. So now we have our slope. We have our point, which I'll label x1, y1. We can use the point slope formula for a line to find the equation of the tangent line. So we have y minus y1 equals m times x minus x1. This is y minus 5 equals, y1 is 5, m is 3, and then we have x minus x1, which is 1. We can distribute here, so we have y minus 5 equals 3 times x is 3x, and 3 times negative 1 is negative 3. Finally, we add 5 to both sides, and we have our wonderful equation of the tangent line, which is y equals 3x plus 2. And this, my friends, would be the equation of the tangent line to the graph of our function at the point 1, 2. So really cool, right? Really nice problem. So again, recap, when you first see the problem, you're asked for the equation of the tangent line. Automatically, you should know, I guess, that the slope of the tangent line at x is the derivative of f at x. That's the most important thing. And they give us the point, so we just need to find the derivative, which we did with this formula. And once you find it, you plug in 1 into your derivative, because that gives you the slope at x equals 1, right? That's the one we want, because our ordered pair is 1, 5. Once you have your slope and your point, you just use the point slope formula, and then you can find your equation of a line. If you enjoyed this video, make sure to check out more videos on Chegg. Hopefully it's been helpful. Good luck.